In a previous video, we developed a test that helps us determine whether a particular force is conservative or non-conservative. The idea is that we take a mass and we send that mass around a closed path as that particular force is acting. Right? We then look at the kinetic energy of the mass at the beginning when it starts out on the path, and the kinetic energy of the mass at the end when it gets back to where it started. If we see that the kinetic energy at the beginning and the kinetic energy at the end are the same, that suggests to us that we're dealing with a conservative force. On the other hand, if the kinetic energy at the beginning and the kinetic energy at the end are different, that tells us we're dealing with a non-conservative force. So in this video, we're going to be applying that test to the spring force. So what I'm going to do is I'm going to take this mass and attach it to the spring, and I want to show you up close. You can see that at the end of the mass there's a hook. So I'm going to take the mass and connect it to the spring, and I'm going to lift the mass up until the bottom of that hook there is level with that line that I drew. Okay. Now I'm going to release the mass from rest, and what's going to happen is that the mass is going to go down and then get pulled back up by the spring. Now, what can we expect to see if the spring force is conservative? Well, I'm releasing the mass from rest, so it's starting with a kinetic energy of 0. So then, if the spring force is conservative, we would expect that the mass would return to that same initial height with a kinetic energy, once again, of 0. On the other hand, if the spring force is non-conservative, we might expect to see that the mass would go down and then maybe not make it all the way back up. Or if the spring force is non-conservative, maybe we would see that the mass starts from here, goes down, and then maybe overshoots. All right, so let's see what happens. Okay, so I'm going to the mass position. Okay, right about there, just where I said. And let's see what happens. Okay, and you can see that over and over, the mass is returning to the release point every time with a kinetic energy of 0. So on a single closed path, starts here with a kinetic energy of 0, returns to the same point, again with kinetic energy of 0. That tells us that the spring force is conservative.